Coulson-Moffit model theory. It is also called as bent bond or banana bond theory. So what is the bent bond? Bent bond is a type of covalent bond somewhat indicative of banana. There are two types of the bonds. First is the sigma bond and second is the pi bond. Sigma bond involves end-to-end overlap. Pi bond involves side-long overlap. Bent bond is intermediate between the sigma and pi bonding. This makes the overlap less efficient than normal carbon-carbon sigma bond, and hence in cyclopropane the carbon-carbon bonds is less efficient than the normal carbon-carbon sigma bonds. Okay, understood? Okay. The configuration of cyclopropane is triangle with bond angle 60 degree. This value is impossible as carbon valence angle can never be less than 90 degree. The angles more than 90 degree, then there is a hybridization occurs. So Coulson-Moffit proposed that the smallest carbon valence angle might be expected to have 104 degree. This suggested that there is a partial overlap between the sp3 hybrid orbitals, and so the carbon-carbon bond may be decreased from 109 degree to 104 degree, and the HCS bond angle increased to 120 degree as compared to normal tetrahedral bond angle. Okay, so this results in the weakening of the bond angle. Hence, this explains the instability of the cyclopropane. But in case of the cyclobutane, the decrease in overlap is less than that of the cyclopropane. Hence, it is more stable than cyclopropane and less reactive than cyclopropane. Understood? Okay. Theory of strainless rings. As per the Baeyer strain theory, the carbon atoms of the cyclic rings are all in the same plane. The strain is calculated on the basis of the cyclic rings are planar. The strain is minimum for cyclopentane and goes on increasing as the size of the ring increases. Hence, members higher than the cyclopentane should be increasingly unstable. But Hermann Sachse soon pointed out that cyclic rings need not to be strained as the carbon atoms of the cyclic rings need not to be coplanar. Okay, understood? Sachse-Mohr theory, higher member cyclic rings can become free from strain if all the carbon atoms of the rings are not forced into one plane. They exhibit it into two non-folded conformations which are completely free from strain. They are strainless as the carbon atoms of the rings lie in different plane and the normal carbon angle that is 109 degree is retained. These are called as the chair conformation, that is the Z conformation, and boat conformation, that is C conformation. The chair conformation is most stable conformation of the cyclohexane. There are two types of the position. First is the axial and second is the equitorial. Axial position is perpendicular to the plane of the ring and equitorial position are around the plane of the ring. Okay, understood? Thank you.